We've all had that sinking feeling, right? A bug pops up out of nowhere and you have absolutely no idea where it came from. Well, today, we're going to stop the frantic guesswork. We're going to learn how to turn Git into your own personal code detective. Let's start interrogating some history.
This right here, this is our guiding principle for the whole explainer. See, every bug leaves a trail. So instead of getting lost in the code as it is right now, we're going to learn how to read the tracks it left in its own history.
Oh yeah, we've all been here. You're just drowning in code, dropping console.log statements everywhere like breadcrumbs, hoping you'll stumble your way out. It feels chaotic because it is chaotic, but there is a much more systematic, professional way to do this.
This is the entire framework. Honestly, any debugging session, no matter how complicated, can be broken down by asking these 4 simple questions, and usually in this order. If you can master this process, you will become a faster, more effective developer, guaranteed. Okay, first things first, what actually changed? I mean, if the app is behaving differently, it's got to be because the code is different. And our #1 tool for seeing exactly how it's different is gitdiff. At its heart, gitdiff is just a super powerful comparison tool. It shows you the exact differences between your current work, the files you're about to commit, past commits, or even whole branches. It is always your first stop for finding any unexpected changes. And this is what makes diff so incredibly useful. You can check your own work before you even save it, you can prevent bad commits by reviewing your staged files, and, this is the big one, you can compare 2 production versions to see every single change that went live. That last one is just invaluable for hunting down bugs in production.
Okay, so diff just helped you find a really suspicious line of code. Now what? Well, the next step is to find its origin story. You gotta ask, who wrote this, and maybe more importantly, why did they write it?
Think of git blame as your historical detective. For any single line in a file, it tells you exactly who last touched it, when they touched it, and in which commit. This is your first major clue to finding the context you so desperately need.
Now we have to talk about mindset for a second because the name blame is, well, it's incredibly misleading. A pro doesn't use this tool to point fingers. They use it to find the person with the most recent context on that piece of code. It's not about finding who to blame, it's about finding who to ask for help. It's all about collaboration, not accusation.
So if blame tells you who, then git log with the -patch flag tells you why. It shows you the entire commit message so you can see the author's reasoning, and it shows you the complete set of changes made at that time. It's basically like reading the code's diary, and it's how you can get up to speed on legacy code without reading every single line.
And now, it's time for the heavy hitter, the most powerful tool in our entire forensics kit. This is the ultimate weapon against that dreaded phrase we've all said, "I swear this was working yesterday."
I mean, just look at this. The difference in efficiency is absolutely staggering. Instead of checking every commit one by one, gitbisect uses a divide and conquer strategy. It jumps to the halfway point in your history and just asks, is the bug here? And based on your answer, bam, it eliminates half the commits in a single step. That's how it can find 1 bad apple out of 100 in about 7 checks. It's just brilliant.
And the process itself is surprisingly simple. You kick it off, you tell Git, hey, this current version is broken, and then you give it a commit hash from a time when you know things were working fine. From there, Git checks out a version halfway in between. You test it, you tell Git if it's good or bad, and you just repeat. Each step cuts your search area in half, and in no time at all, Git literally tells you the exact commit that introduced the bug.
And this is where it gets really, really powerful. If you have a test script that can automatically tell if the code is working or not, you can just hand the entire process over to Git. You run git bisect run with your test command, and you can go grab a coffee. It will do everything for you and present you with the single bad commit at the end. It's automated root cause analysis. It's amazing. So, we have all these awesome individual tools, but the real power, the real magic, comes from combining them into a single systematic workflow. So what does that look like in practice?
The key here is to follow this order. Start local with your own changes. Is the bug even committed yet? If it's not there, widen the search to recent releases. Still no luck? Okay. Now you can zoom in on a specific suspicious line with blame and log. And only when those fail, only then do you bring out the ultimate weapon, gitbisect, to let the algorithm find that needle in the haystack for you.
You know, the real takeaway from all of this isn't just a list of commands. It's a fundamental shift in how you see Git.
It's not just a tool for saving your work and pushing it to GitHub. It is a historical database of every single decision ever made in your project. It's a forensic timeline and a powerful debugger all rolled into one.
Look, strong engineers know that the code they're staring at might be misleading, but the history never lies. They don't debug by just looking at the code. They debug by interrogating its past. They just ask one simple question: when did reality change? And with the tools we've just covered, Git will always give you the answer.